we have a function given to us here. We recognize it as an exponential function. Radioactive substance radium-240 has a half-life of 14 hours. The, half of it's going to be gone every 14 hours because then you're going to multiply by half. The amount A of a sample of uranium-240 remaining in grams after T hours is given by this following exponential function. And again, this, I believe, in chemistry is the way they usually address half-life questions, because you always get the half-life. Find the amount of the sample remaining after 13 hours and after 50 hours. So we've got to do 2. Basically, T is the hours, so we're plugging in 13 for T, and then we're going to plug in 50 for T, and we'll get 2 different answers. Rounding to the nearest gram as necessary. So what I'm going to do, since we need to get 2 answers, let's go with what I find to be the quickest way to do that is looking at the table. So we're going to enter this equation as 2400 times 1/2 raised to the x divided by 14. And then we'll just go to the table. We'll look up 13 and we'll look up 50. If you'd like to get there a little quicker, we go to table set. I'll show you. Table set, what we could do is we could change this to ask instead of auto, because there's a big difference. Or you could just scroll if you want it. But if you change it to ask, when we go to the table, it's going to ask us which values do you want for x. Well, I want 13. And so it plugs 13 into the function and gives us this answer. And then 50, I put 50, plugs in 50 and gives me this answer. So notice it's going down because it's a half-life. We're losing some. And so I come here. Sometimes you have to do this with particular rounding. This one we don't really, since they want rounded to the nearest gram, this is 1,261, no decimal grams. And that's for 13 hours, right? So I can see that. That's the nice thing about doing that. I see the 13 right there, and there's my answer. So I can put that in, 1261. For 50 hours, I see it's 201, but there's an 8 there. Round that up to 02. Round it to the nearest gram. Now, if you didn't have a graphing calculator, hopefully you got a scientific calculator, you're going to need something, because what you're going to do is you're going to plug in A of 13, right? 2400, 1/2, or you could put in 0.5 because that, either way. And then up here, you're going to go 13 divided by 14. Now you're going to want to get this all in on one line, and it just depends on what calculator you're using. But this actually, I think, is the harder way to go, because there's more areas for error, because you're going to enter this twice, and this is a part, some of the older calculators doesn't put it up here. It puts this little symbol, and then you have to make sure you have a parentheses. Now, we don't need it for this calculator, but I'm going to do it anyway. Again, you've got to, because your calculator is going to follow order of operations. Notice I'll get the same answer, 1,261 rounded up. But I can do this, and then I'd have to do it again for the 50 hours. 1 divided by 2 raised to the 50 divided by 14. But if you can just sort of automate it, look, it came up a little different. I'm not sure why. Oh, actually, in the calculator, in the table, it was rounding this 8 up to a 9. So it's actually exactly the same answer. If we go back to the table, come down here, right, 885 but it rounded it. So anyway, a little concerned with that. So that is, which one was that? That's number 11.